Okay, so finally on air. Yeah, then thanks for inviting me to this Jack meeting. This time just an online one, not personally in Australia. I hope to be in Australia soon again, if it is allowed, this traveling, because I want to be in Melbourne, see my friends. I want to see my friend in Sydney. And yeah, well, so I'm just waiting to come again. So this time online. And I have to say one thing in advance. This is the first time I give exactly this talk. So you are the first audience for this one. And this is more or less a summary from a research I needed to do by myself. And yeah, well, let's start. So, well, I think a lot of you saw me in Melbourne already. Maybe not everybody, but my name is Sven, and I'm working for Jfrog. I'm developer advocate there and focusing on DevSecOps. And well, working with Java since a long time, and mostly in boring, big legacy projects. It means I have no idea about cool new stuff, just how to deal a long time with what you have done before. Okay, so the most important thing, what we're doing today. So the topic is persistence, high performance persistence with focus on less infrastructure. So we have a lot of persistence solutions. I will give some basic ideas, what I'm thinking about or what I'm expecting or what was the main point to search for exactly this candidate. So I want to give a short intro. And the main thing is here that I want to focus on something that is easy, that is fast, and it's not a technology monster. So agenda persistence, bird's view is just basic ideas, some questions, some thoughts. With this, we are narrowing the border around the huge thing, persistence itself. There's one thing, MVCC. Some people know it, some people hate it, some, well, just a few ideas about this. Then we are going to some examples I have here, so that you have some projects to start looking at, and then what it means or what was my experience in the field of as a developer handling this one, dealing with DevOps, DevSecOps stuff, and some additional content. Okay, after this, I think we can have something like a Q&A. I will show something on my IDE maybe, or some practical stuff, but this I think is optional for the people that already had a long day. So, oh, by the way, can someone see me? No, I think with screen sharing, nobody can see me, because we have these cool shirts. There's really cool shirts, there's frogs. And if you want, you can get one of them. So all this stuff I'm presenting here, so it means the slides and some additional information, all this stuff will be shared on jfrog.com/show-notes. And there is one for today, one subsection. And there, if you want to have, you can fill out this form and try to win one of the shirts. Otherwise, you have to wait until I'm in Australia again. So that's the main thing. Okay. So persistence bird's view. Oh, by the way, how we want to do it with questions. I know that we can write questions in this chat, but I'm not sure if I see them during the time I'm using PowerPoint. So that's the only thing. So if I see them, I will try to give an answer. Otherwise, I will do it just later if I'm stop sharing my slides. So, okay, persistence bird's view. I think it's trivial, more or less, but if you're talking about persistence in general, you have something in your app, you have something like an app model. So you have a bunch of classes, classes are connected, yes or no. We are talking about a graph. And this graph is influenced mostly by the core data structures we have in Java. It means in the end, we're just shifting around basic types like integer, string, whatever, and data structures like maps, lists, arrays, whatever. I think the most people are just using the core data structures and they are not creating their own data structures. But in the end, it's some business logic based on core data structures. And then you're working on this. You have different things in mind. For example, if you have to deal with data structures that are just used by one instance or concurrently used, so you have different technical aspects on this one, but in the end you have core data structures. So I just want to isolate these core data structures, and I don't want to have in mind too much this transactional thing. But then if you want to have a performance, whatever performance means, so some people say 10 transactions per second, other people think 1 million transactions per second. So I don't want to deal here with numbers. I just want to say, if you want to have it fast enough for your specific needs, then quite often you have in bigger projects, or whatever big means, but in projects, something like a caching layer. Typically, you have this caching layer on top of JPA. And that means that the cache itself, the implementation of the cache quite often will push you to some model mapping already. So you have your data structure in your app, and then you have the first layer, this caching thing. And then the first thing you have to deal with, or quite often you have to deal with, is that the caching mechanism itself, so a technical thing, will force you to change your model. And this is something that could change. So if you're changing the technology, the caching technology, you have different options of dealing with it and a different pressure to change your model mapping. Oh, by the way, if you hear my daughter running around or whatever, they are all at home. So so you have in this, with this cache, the first need to transform your data. Transforming data means you're losing time, you're burning CPU cycles. The next thing is, immediately, if you're talking about caching, you're talking about eviction algorithms and all this stuff. So how fresh this data is, and this is time consuming as well. So not only the implementation of this eviction algorithm, the data itself will have delays. So, and this is not good for high performance, whatever high performance means, low latency or whatever. And then in the end, from this caching mechanism, we are going to the really persistent one. Persistent means something that will store the information during the time I'm switching off the power and switching on again. So, and again, we are talking mostly about a model mapping. Here is very explicit. It means I'm going to a relational database, I'm going to key value store, whatever. And I'm mostly dealing with engines, storage engines, and inter-process communication on network. It means you have a different process on the same machine. You're going over the loopback device or whatever, or you really have something like a wire between your app, the cache, and the engine. So all this is influencing persistence, my way of thinking about modeling, the way of dealing with performance, the different techniques. And if you have to deal with all this stuff, it really depends on your needs for example, testing. If you say, I want to test my app, I'm just testing the app structure, but I'm cutting off the cache. I'm just testing the persistence layer, but without the cache. So how to make the right cut for your testing. And if you're testing the full stack, means you have to deal with a lot of infrastructure. So the first thing, if you have this bird's eye view here, and you have all these different layers, for me personally, I have different questions. So for example, if you're looking at your data, mostly you can say you have the data is not stable in the same way of the whole data structure. In some projects we have, for example, just the need to store stuff. So you're creating data, you want to persist it, and you never touch it again. It's just written down like event storage for transactions or whatever. They're just storing it. The next thing is you could have some kind of sliding window with your data. So you have some amount of data that you are actively working on, changing, deleting, or maybe querying. So this even is something that is influencing your architecture. So you have the sliding window, and then you have this rest of data that's just on a long living medium. And it's not even possible to have a talk query on it. So this one, or you have the worst case, all data is hot. Just everything in your database will be changed, queried, added, deleted, whatever. So this is one thing. And then if you're persisting data and you have these different layers in mind, you have to think about how to query this data, so how to deal with this data. So a persistence layer will need some kind of questioning. So if it is SQL, if it is Cypher, if it is Core Java streams, whatever. So do you have to learn a new way? Do you have to formulate your question based on technical needs? And if you're thinking about navigation in this data stuff, in your data store, you have to think about, do you need all attributes or just subset? Do you have calculated fields, something like views, so manipulating of the data during the time you're querying, or can you isolate this one? So this will, having this in mind, you will see that in your application, you can mostly clearly divide between the three layers of writing one sliding window of data. And if you are able to divide this one, you have sometimes very good chance to get rid of a lot of technology. Okay, some basic thoughts. I think this we had. So the one thing, if you're dealing with data, and especially if you're dealing with high performance persistence, you immediately have this caching or this concurrent read-write modification stuff on database. Most people know it under dealing with transactions. Transactions is or this exit thing is the most people know it from SQL databases, but there's several other ways to deal with concurrent modifications. One thing that you should have a look at is MVCC. MVCC you will find under this one, under this URL, a Core Java implementation. A Core Java implementation that's just giving you the implementation of this multi-version concurrency control algorithm. It's a standard. A lot of tools are using it. So if you're really looking into detailed documentation of database, you see that a lot of databases are internally using exactly this model. And if you're going to this Core Java or to this tiny persistent frameworks, it's good to know that you have this strategy, and some of these implementations are implementing it, some of them are not. And then it's good to know that you have here a Core Java implementation of this MVCC that you can use for analyzing or just to use it for your own. So the main thing here is how to deal with concurrent modifications in an in-memory thing. Because if this is complex, or if you have to lock, so everything that you're locking is destroying performance mostly. So what you want to have is a non-locking technology, so that every task can run as fast as possible, and only the technology is limiting, not the algorithm. So, and well, have a look at this. The theoretical point behind this is a little bit more complex, so you need some time to read it and play around with this to really get your head around this. But there is a Core Java implementation. That's the first point, and there's good documentation. Even you can start with Wikipedia, and from this you will just find enough. And the project I showed you here is quite old. I think 7 or 8 years old, and it's stable. So from this, have a look at this one. But with this, you are able to deal with in-memory representations of data and dealing with concurrency here. Okay, so based on this, I needed persistence for some projects over a few years now. So it's nothing that I've done just the last month. So over the long term of, I don't know, at least 10 years or whatever, you always had this, I need some data. It's not so much, and I don't want to install a relational database, this typical SQL store, because I have to ramp up a new infrastructure. I have to deal with this JDBC layer and all this stuff. And so I started looking around, and all the time, this is not a chronological order. This is not my preference order. This is not, it's just some order. I'm presenting this project here, and they have different pros and cons. But all of them are working in memory, so you don't have to deal with this explicit ramping up of infrastructure stuff. XODUS, so I don't know how to pronounce it. I have to ask at a conference, maybe one of these JetBrains guys. So this one is from JetBrains. For the people that don't know JetBrains, they're creating this IDE, IntelliJ, and UTrack, and AppSource, and all this stuff. It's a company that's since a long time working in the field, and they're very, very good in theoretical stuff with compilable languages, mathematics, and all this stuff. So mostly if they're creating something, the technical background and the theoretical background is really, really good. So, and they needed for themselves a persistence store for, I think it was UTrack, the issue tracker. And they created this transactional schemaless embedded database. It's more or less in the end, it's a document database, so that you can just push stuff in. And what they achieve with this implementation, it's open source. You can go on GitHub, you can just clone it, you can play around with this. You have transactions. You have here the first time reference is MVCC, so that you know how data internally is represented if you have challenges with snapshots or isolation. And the main thing is it's embedded, and one important thing, it's pure Java. So it means I think there's not really a dependency. So you have just the implementation and the JDK itself, and license on Apache. If you want to have a look at this one, you will see that you just need 2 dependencies. You need the Open API, the API itself, and then it depends what level of abstraction you want to have. If you want to have environments, entity store, virtual file system, then you're just adding the implementation of this API, and that's it. So you can have different abstraction layers or levels of abstraction in different modules. So, or maybe it's the same module, but mostly it per module. So with this one, I want to have a look at this environments. Environments is at the core level of this one, and it will give you the possibility to deal with a key value store. So you have 2 different things with a key value store, just like a hash map. You have a key once, or you have a key multiple times, and you have a multi-map. But in the end, what you can do is you're creating a new instance on your disk, and immediately after you have done this, you can start working with transactions and pushing data to disk. So it means it's a very easy and straightforward thing if you need a key value store. So if a key value store is a good one for you, this could be a straightforward way. You have a dedicated point where data is stored. So if you're closing the app, you just make a backup of this, and that's it. And everything must be executed in a transaction, so you don't have the possibility to execute outside of the transaction, if I'm informed right. But the main thing here is you're dealing here with identities of data structures. For example, you have here an open store, and this means give me a store without duplicates, so a hash map for this or bound to this transaction you have already. And the identity has a name messages. So if you have somewhere in your application, a constant or whatever, then you can share this one, and you can go from every part in your application. If you have this environment as a static instance somewhere, you can access this data store, and you just need to know the name of a data structure. And in the end, you have here a hash map with the main with the name messages, and then you can store data. One thing you should have in mind with this implementation is that you see the string binding, string to entity thing. So every data that must be pushed in must be encoded in the way they are thinking it's right. So this is a very core thing. If you want to have a little bit more luxury on top, you can go to this entity stores. Entity stores is their way of dealing with complex attributes inside of transactions. It means you can have now different entities, and they are linked together. They have this ID concept, and then you can build up graphs with a key value store. You're not able to, or you have to implement graphs by yourself. Here you have a mechanism to build graphs. And here it's exactly the same. You say here at this place on my disk, I will start with my entity store. I'm start a transaction. I'm grabbing a new entity called, and then you have your ID again. So, and on this one, you can set properties and get properties. What you have here is more or less a bucket of different properties with a name and a value. And then you can link this together. It is some kind of entities, but it's very limited because everything must, so every attribute must set and get and all this stuff by yourself. So if this is enough for you, there's an easy way, and it's transactional. And then they have a different thing on top of it. It's not an extension of the previous one. It's an extension of the first one, the environment. It's called virtual file system. And on this virtual file system, they will give you exactly the same possibility, creating a new instance somewhere on your disk. And then you have this virtual file system, and then your this implementation is more or less optimized for dealing with input-output streams, writing byte streams, and all this stuff. It's a different way of writing stuff down. But in the end, it's more or less the same. So you have this key value store. Everything must be mapped more or less in a key value behavior, and then you can write down this one. Sometimes this is exactly what you need, but the challenge here is how to query data. So there's not really a query language or a query API on top of it, what I was able to find. So it means you are really going to an instance, you need to know the ID of the entity you want to have. For example, here, this messages or whatever, and then can work on this one. Okay, then this is the sort of thing is quite complex already, but there is a little bit easier thing that you can have. Chronicle Maps and Bytes are two different projects under the same hood. This is more or less dealing with persistent data structures here. Maps and bytes I will show, but they have queues and all this stuff. They are coming from this banking environment, so low latency stuff, mostly perfect for writing stuff immediately down without any bigger transaction stuff. So Chronicle Bytes is just off-heap storage, or you can use it with off-heap and just use the fastest way to write down more or less it's sun, miss, unsafe, whatever thing. Yeah? So, and operating system calls. And a little bit more than just bytes writing down is map, and then they have queues and all that stuff. The main thing here is you have a very fast technique, but you must have in mind that you must be careful with the JDK you're choosing, because they are saying it's running with the JDK ABC, with vendor whatever, and then you should use exactly this one. It could work with others, but immediately if you're going to off heap and you're not dealing right with this implementation, it can just kill your JVM. Sometimes you need this risk because you need this performance. Sometimes it's just overkill. But here you have bytes and maps, also on GitHub. And if you just want to write bytes, so you really have raw data and you just want to pump it down, then you have this Chronicle Bytes. You have this bytes class, and then you have the different possibilities to create memory allocations. Here it's an elastic heap, byte buffer, then you have some different. So there's a huge bunch of different variations of how to allocate data. But the main thing is that you're just writing bytes, ints, UTF-8, whatever. So you have a very fast possibility to write down stuff. The implementation is not limited to the memory you have in your machine, because you're just writing down to disk, and it feels like in-memory computing. But you have to have in mind that it's very, very JDK specific. So you have to be careful that the JDK is really one of the tested ones from them. And with this, it depends on their cycle of bug fixing and all this stuff. Other thing with maps, if this just writing down raw data is not enough, they have maps or queues. And here what you can do is you can have a map with type A and B. And to use this one effectively, you need to know your data. So if you have a really big variance in your data, it means in for example, if you're storing strings and you don't know what's an average size of the string, if you're dealing with 10 characters or with 100 characters, this is mostly not very efficient, because you have to say every map, for example, what is the amount I'm expecting and what's the average value. So how long or what's the average value of the data you want to store there. And based on this map is pre-allocating stuff and dimensioning internally constants and all this. So if you know a lot about your data, because you're just writing down events or data that is very the same mostly, then this one is a very good one, and you can just write this stuff down. For example, if you have an Hazelcast cluster and you want to persist the map itself, then you can go with this one, and it's a very fast solution. But again, we're talking here about core data structures. So everything you have in your business app and you want to store with this, you have to map back to basic data structures. And this is, so it's a different way of mapping compared to XODUS, but it's again a mapping. And I was not really happy with this one, so I just searched a little bit more. And since a long time, I'm using in different projects MapDB. MapDB is now a little bit, yes, has some cool features. For example, MapDB is, so the guy, it's maintained by one guy. So XODUS is by the company, Chronicle is more or less by one guy, maintained with a few people around. MapDB is just maintained by one. So this is maybe a little bit critical, because the development on this one is not stable. You have to have this one in mind. But if the version is running for you, this one is again an in-memory solution. It's just one dependency. It's written in Java and Kotlin. And what you have a drop-in replacement of maps, lists, and queues, so a bunch of collections, and you have a very cool possibility to combine them. So you have the possibility of off-heap maps, but not necessarily. So if it is not working with your JDK, it can just, or you don't need off-heap, just don't do it. But the cool thing is here, you have this multi-level cache structures, or you can cascade these data structures. And how to deal with this? So you have only one dependency you add, and then you need first to declare where's the place you want to be. And then you have to make a decision if it is a file system or if it is an in-memory thing. Here, I'm just saying dbmaker.filedb, and then the place I want to store stuff. If needed, you can encrypt it. And the only thing to make a backup is just gz this folder, and that's done. If you have this DB, you start again with creating identities of data structures. So here, for example, I want to have a tree map with an ID, with a name, and then I have to deal with this serialization stuff. So again, I have to deal with how to serialize my data. The same in Chronicle and Bytes. It's a little bit more hidden, but always you have to say what kind of serializer you want to have. Sometimes you have to provide your own serialization stuff. So it could be tricky if you're not going over the default types. But here you say it's a collection with integer and string. If it is available, just open it, otherwise create it. And then you can put values in this data structure, and you have transactional behavior here already with commit and rollback. In Chronicle Bytes, you don't have it, so every data is just written down. But here you have already this MVCC implemented and on top, so you can use this one for transactional behavior. And again, you're back on data structures. So if you need something that is with hot data in memory and with persistent data on disk, so if you can divide this here a little bit, you can play around with this cascade of data structures. Means you're creating one database on disk, this first one, FileDB, somewhere on disk, and then you're creating one in memory. So you have different stores now. And what you can do is you're creating, for example, a hash map on disk that's going over the DB disk store, and then you're creating an in-memory implementation of it. So you're creating a hash map again with eviction behavior, and you say expire overflow on disk. So everything that the eviction algorithm will give free will be pushed to the hash map on disk and stored. You can even say in executor, for example, if you have different possibilities to dimension your eviction algorithm, how many resources, how many threads, and all this stuff. But the cool thing here is that you can build hierarchies, and the hierarchy is not limited to this combination. You can build more hierarchies based on your needs, and this is a cool thing because you have it on disk as well as in memory, and then you have a cache. You don't have to map this data by yourself between both of them, and you can just deal here with dimensioning your resources. This is a very easy one, but again, you're dealing with core data structures. Again, you're back on maps and queues and all this stuff. And if you really want to get rid of this one, last year I found a project that will give me exactly the same stuff, plus I got rid of this mapping. And this is a project that's a tiny company in Germany, but they just got seed funding so the development is at least for the next few years safe. It's called MicroStream. The only thing here is it's free to use, but it's not open source. So if you need it as open source, this is no way to go because you have no access to the source code. But if you're just looking for something that you can use free and just want to pay for support and all this stuff, then you can go with this one. So this is one of the difference between the other things, but you can use it for free. So you don't need some license or whatever immediately. I think for Yeah, I think you only have to pay for support also, but check it, have it in mind. But MicroStream is a technology that is just writing down the whole graph. So if you have an in-memory store and you have built up your domain model, you can just say store. That's it. We had this one, so techniques like this with object databases long time ago, but mostly it was a little bit pain somewhere because you have to deal with special inheritance things and all this, and this is just not the case here. So I tried it with a few things. I have some articles on dzone where I try to destroy a few things with this, and it's really nice. So you have just a data structure, and you just say, here's a store, store it. That's it. And this one is really fast. So they were able to build some kind of serialization or a new way of serialization, but they don't have the security issues what we have with serialization. So I don't know exactly how they have done it, but my tests are okay so far. So what you need is a dependency, this embedded store and this configuration. And they're just hosting this stuff in their own repository. So, well, you have to add this one, or if you're using something like Artifactory, just add in your remote repository and add it to your virtual repository. But the cool thing is really you're just writing a class, there's no inheritance, nothing needed. And then you're creating your storage and you say, here's a root from my graph and stored. That's it. And this is by far the easiest thing I was able to find. And until now, I was not able to destroy it, even with cycles in the graph. So I really try to kill it somewhere. So like having A with a reference of B, having B a reference of C, and having C a reference of A again, and try to see if you can write it down, if you can load it, and all this stuff. So cycles are not a challenge. Inheritance is not a challenge. I really played around with default interfaces and all this stuff. This is sometimes challenging if you're going, for example, to Chronicle. If you're going to Chronicle to get a value, a new value, you have to say, Chronicle, please create a new value. And then you have these interfaces. You don't have an implementation of your data class. You have just the interface declaring this. And then Chronicle is in the background creating the class and will give you an instance. So sometimes it's perfect to use. Sometimes you can't because you have to deal with inheritance in some way or whatever. Here it's just write what you need, dump it down. If there's no transactional stuff, so it means they don't have transactions. If you're reading on their website, you can see transactional stuff you have to do by yourself and so on. Well, it's not the easy thing, but just think about that you have an implementation of MVCC and other implementation are just using this technique as well. So I think MVCC on top of this one will give you transactional behavior. But I haven't done it by myself, but I think this would be the way to go. If you really need transactions like this one. If you have a really huge graph and you want to load it partially, so for example, if you're dealing with Chronicle or whatever, you just can say load it and then it must fit, or you have to go with this memory map file stuff on disk immediately off thing. The same with MapDB, you can build up these hierarchies so you can have a bigger amount on disk and just loading the hot data in the in-memory storage. So this is okay. The thing here is they're dealing with virtual proxies. So inside your graph, and this is one thing I personally not really like, but it's the way they're going, is that you have to build this virtual proxies by yourself. So you can't go in and say load layer 1, load layer 2, and they're not loading layer 3. If maybe they changed it now, but so far I have the experience. If I say please load this graph, then it's loading the graph. So otherwise you have to build this lazy reference in between, and then you can say, okay, load until this point and then load the next one. Yeah, that's it. It's in memory as well. Yeah, this I already mentioned. If some of these tiny libraries is not giving you transactional behavior, have a look at this MVCC and this core implementation. Maybe this fits already. But there are some ideas or some things you should have in mind. Whatever you're using of these persistent frameworks, and even here, so what I've done before I'm adding something to my project, I make some security research and some compliance research. Well, this is from the DevSecOps part. So if you have this core DevOps part, you have mostly these developers and these operations, and quite often I see that the devs are using stuff, it's running well, and then on the ops part you have this, yeah, the first time checking the license, or they're analyzing if there are some security issues and all this stuff, and then you're burning a lot of time and money. So it would be good if you're doing it immediately in the beginning. So even if you're analyzing different tiny frameworks, you must have access to security information. So for example, if they're using transitive dependencies with some critical things, here you're talking. So I don't want to go to DevSecOps now in detail. If you want to more know, I can have a dedicated talk about this one, or just check my tutorials. But the main thing is, whatever you're choosing, check immediately what's going on. If you're dealing with JavaScript, you know what I mean. If you're checking transitive dependencies, but it should be somewhere in a way that adding a dependency and immediately you see what's going on. So my personal things based on what I presented to you here right now is, my experience is the small amount of components is mostly easier to handle in the ops part, in the dev part, because if you want to write tests against your persistence layer, and this is mostly pain. So if I have to deal with my persistence, I start mocking. I don't like mocking because I'm just rewriting the whole stuff again, and it's not the same behavior. So I want to test against the real infrastructure. For example, if you're dealing with Postgre or whatever, test containers is a really, really nice open source project where you can just RAM4J unit test your Postgre, push data in, write your test, destroy everything, and again, and it's fast. But it's even faster, and it's a big difference if you have thousands of tests, if every test will take 10 seconds or 15 seconds or 100 milliseconds. So ramping up and ramping down this infrastructure must be very easy. And it must be in a way that you can do it on your machine itself. And with all these in-memory techniques we have, or I've shown you here, you can ramp up and ramp down this stuff immediately. And it's really fast. And you can handle really a lot of terabytes with this on your laptop. So without, yeah, okay, if you have enough disk space. So, so this is one thing. One thing you should have in mind is data migration. I don't talking about data migration between Postgre and MySQL, or Postgre and Cassandra. I'm talking about data migration even between versions. So how to migrate data, or if you're storing, for example, with MicroStream, the whole graph, and then you're changing the classes, how this framework is dealing with this one. So how is this framework able to read the old version and convert it to the new one? Partially, I tested it with MicroStream because it's the only solution I presented here with. There's a Java class graph, and I'm just pushing it down. So there are some functionality of merging from version 1 to version 2. But I will test this more in detail. I haven't done it so detailed. So this you should do by yourself as well. And then with data-driven testing, it's very easy. All these tools I showed you, they have somewhere on a file system just a binary dump. What you could do is, if you have a data set, a reference data set, just write it on some machine down, create, for example, in Artifactory or whatever, a generic repository, and then you can have on a central place for your whole company, one place where all your data sets are immutable stored. And this will speed up your testing environment. You have the reproducible yeah, everything is reproducible because you have this reference data sets and you can deal with it. But some things are not nice. For example, talking a little bit about tooling in a few seconds. But the good thing is everything is completely managed in Maven, so you don't have the semantic break. And if everything is managed in Maven, you can use all checking tools based on Maven as well. So for example, checking if all transitive dependencies are available, you can just use everything that can handle Maven, and then you have the same quality about the whole chain. You're not switching to a different system. And the same with license. So everything that's organized by Maven, Grell, or whatever will give you the possibility to check what's going on with the license and the transitive license, because you have the whole graph. Then you can check if over all stages, for example, you're not using a license that will just kill your business. So the good thing with this Core Java stuff is you have IDE support. You don't need a special plugin. Not only one of these frameworks I showed you need special plugins like Lombok or whatever. So if you're using Lombok and you don't have this plugin in your IDE, it's not nicely working. So here you just can use whatever IDE you need, because you have a Core Java API and that's it. You can navigate through, you can even navigate in this stuff. So that's a good thing. And the integration in CI environments is just easy. But all of these solutions, they are not perfect if you want to have ad hoc queries or if you want to have the possibility to navigate through this in a visual way. So for example, if you're a database like Postgre, you have your tool, you just connect to the table and just push some selects in to understand what's going on here. All of the solutions don't have strong tooling there. So have this in mind if you have to deal with this one, but backup and restore is just easy, just copy, paste, that's it. My personal view, pros and cons about this one is, I think this XODUS is a very, very robust version, and it's very good if you need strong transactional behavior, but just if you have this document-oriented data structures already. Otherwise, you're just pushing a lot of stuff or a lot of work and effort in this data migration, data mapping stuff. Chronicle is perfect if you have to deal with data that you're just writing down and mostly not touching again. So really, if you need a way to just write as fast as possible stuff down, limitations from my point of view is that you must be careful with the JDK you're using. So just use the JDK version and vendor they are recommending. Otherwise, it could be just crash your machine. It's really fast, but if you're not closing a data store right, it could just crash your whole JVM. MapDB is a quite cool tool and robust, and it's since a long time running. So as a version 3 is just good. If this fits to you, this is a stable thing. But you are backed on this mapping to data structures like maps and queues and all this stuff. But you have commit and rollback. And the good thing is you can build up hierarchies. So if you have partially hot data structures and cold data structures, so you want to persist on this, but you want to have for very fast access via streams and all this stuff in memory, then this is a really good way to go. But again, you have this mapping thing. MicroStream itself is the youngest one, but I'm really impressed by how this classes could be just stored and loaded. It's really robust against cycles and all this stuff, so it's really working well. Disadvantage is definitely you have to do this transactional stuff by yourself. Maybe you don't need it, then it's just fine. If you heavily need it, you have to invest in some transactional knowledge and implementation like MVCC, what I would recommend to put on top. From the risk point of view, XODUS is, use by JetBrains, maintain by JetBrains. So this is, you have a company you can talk through. Chronicle is a guy that's mostly the person behind it, has some other people. It's not a big crowd, but some people are available and you can buy support. MapDB, rock solid. If you're just using it and you don't run into an issue, it's fine. Just use it. It's really nice, but it is one person. I'm not sure if you can buy support. I never saw it. And the development is just unpredictable. So you don't know if he's now working on version 4 or not. If you can use the existing version, it's cool. It's really running well, but don't trust his roadmap. So if you need something that is on his roadmap, yeah, the timeline is unpredictable. MicroStream is a company again, so you can buy support. So if you need this one as well, but have in mind that the transactional stuff is something you have to deal with. Okay, these are more or less my personal things. I created a repository where I added all this dependency, and I can show after this, during the time I'm answering questions, I can show you inside the IDE how this looks like. But if you want to try all this stuff out, you can start a trial and use the repository for the compliance and the license check so that you can see what's going on. Because we have, if you're checking this one, right now at the moment, we have one of these projects with a security issue. It is a security issue over a longer time. If you need exactly this functionality, you have to decide by yourself and so on. So here's a URL for this demo repository where I added all these dependencies, and just type your first things in. And yeah, well, you can use this with a free trial. The additional content, where to find this, I added all these links to the slide so you can see where to go. And yeah, don't forget to burn your shirt. No? That's the most important thing. So finally it's done. Okay, so far, this is the things I want to say about this performance stuff. Explicitly, I didn't add numbers because all numbers would depend on my machine. So you have to test it by yourself if the numbers are good enough for your stuff. But I can say all the solutions we have, they are really, really fast, and the memory footprint is really, really good. So thank you so much for this one. And I would say I stop sharing my screen so that finally you can see my nose again, and we can have this Q&A stuff, huh?
Yeah, it's pretty heavy, but it was pretty good, I would say. I think it's really good to see your research of pros and cons of different things. I think that's the quality of a solution architect which you have shown. That's probably the most difficult thing, rather than just taking off the shelf libraries and use it as we all do.
If you're reading the READMEs, everybody is the fastest, the best.
Who reads the README? That's my statement to all the devs. Who reads the README?
Same like Java Docker, first delete it. Yeah.
Awesome. So I would like to ask the audience, first of all, thank you so much, Sven, for an amazing presentation. And I would extend my request to the participants. So we have almost 30 now, 25 participants. And if anyone has got any questions or any feedbacks, please feel free to unmute yourself and ask.
Don't be shy. I'm just a few thousand kilometers far away. I think Timothy, I saw Timothy here shaking hands on this matrix of pictures.
Technically, it's supposed to be a clap.
Oh, clap.
Thank you very much for sharing and going through all of that.
Okay. Yeah. Well, best thing is try it, and then I'm really eager to know what's your experience with this stuff. So I really would like to get some feedback of trying it by yourself and what's your experience with all this. So I really want to learn, because I need this stuff. There's one project in Sydney. I'm just thinking about what's the right tooling for this one, because we have there something about session positions. So yeah, well.
So I've heard that. So like in my previous startup, we are using Redis for storage, temporary storage. So how would you kind of rate that? Because even Redis was kind of in memory. It's like a hash map, right? Map of maps, basically.
Yeah. So, well, the main thing is why I selected this one instead of the bigger known one. First of all, if you're searching for this one, Redis will immediately in your search result list. That's one thing. So I want to give smaller projects a chance. That's one thing for my selection. The second thing for my selection is that the solutions compared to the traditional one are mostly very lightweight, and you have a chance to look at the code and learn and to change some stuff. So all these projects are small enough. The only exception is Chronicle, because you're going immediately to this off-heap stuff, and this is the tricky beast. So you really have to know what's going on there. But all the other stuff is just Core Java. I don't want to deal with different languages. There are some projects with Kotlin inside, but if you know Java, you can read Kotlin somehow. So this is why I'm selecting this one. And Redis, compared to the other solutions that are just mapping to key value store, is not so big. It's just a different syntax, and it's just the main point. Your data structure mapped to hash maps. And then you can replace Redis with Hazelcast, with, for example, Chronicle Maps. You can just change them. It's a little bit different API, but it's always the same pain, mapping everything to hash maps.
Right. And I think MicroStream is probably, I have never heard of like directly storing your objects into the way they are in the memory. So that's probably the newest thing I've heard. Probably.
Yeah. So I saw them, for example. So I know this company because they're in the south of Germany. So they are running a JAG. But I saw them that they are heavily discussing with Brian Götz at Java. No, not Java 1. It's now Oracle Code 1. And they're heavily discussing with Brian Götz, and he was a few times at their booth. So if he's coming 2 times to the booth to ask questions, maybe it's not the worst solution they have. So I trust Brian Götz.
Yeah, makes sense. Makes sense. Or I'll ask questions if Con or anyone else has any questions, any of the audiences.
I love how you just throw expect that I would have a question, Neil.
You usually have that.
So, okay. I didn't think I'd have a question, but I do. I actually came across this thing last couple of days, RocksDB. Have you heard of that? Sven?
RocksDB, yeah. I heard it, but I don't have it in mind, so I have to.
So it's basically another in-memory data store. I don't know too much about it. I just know a product that I'm using at the moment is using it for its in-memory data store.
It's from Facebook.
So apparently it's inspired by Facebook, or it is Facebook.
It is Facebook.
So, but it is another in-memory data store. They do have, it's C++, but they do have a Java API. I was looking while you were talking just to go, what's the difference? But I couldn't see anything about that that persistence model that it had. So, your guess is as good as mine about that whole MVCC thing there.
Yeah. They have transactions. I see example with transactions, but they're going down to adding Bloom filters and all this stuff. So I think and you have different compression types and statistics. Yeah, it's worth looking at it. So thanks for this one. So I will have a look at it. So, but if I see that you're changing the implementation of a Bloom filter, then I think you need some time to understand what's going on there. Yeah, cool.
I'm curious here, anybody else on the call, do they have any use cases for these in-memory stores? Because I know, actually, as a matter of fact, with the Chronicle, I don't know if you're aware, but the guy who started Chronicle is actually from Melbourne. And
I know.
Yes, and
I know him.
You know him, Peter Laurie, so he's presented a few times here as well on Chronicle. But they also, you said the financial institution. So there is a financial institution in Melbourne that does use Chronicle quite heavily. And I think I'm not sure, I'm just putting it out there to other people on the call who, do they have any other, really quick persistence mechanisms and well, curious what they use, even if it's stuff in the cloud or, like some sort of cloud cache or something like that.
Well, sometimes it's even just convenience. Huh? So if you can just store your whole graph or your hash map just right to disk and read it, sometimes convenience, not the performance you need. So for mid-age projects, just 10 users or whatever in a company, and this is a critical process, but just 10 users, but you want to have a persistent, and then sometimes this is just a good solution, whatever you choose of these projects, because you can just store data and read it, and you don't need extra hardware and containers or whatever. So then performance is not really the critical thing, and it's not only in memory, it's really storing to disk what all of these tools can. And this was one point to select them, how to. So even Chronicle Maps you can store on disk and read it later again.
Yeah, I guess, it's an interesting thing, I guess, if you've got a distributed storage, I guess, because otherwise you've just got, why not just have a Java processor just use your memory? Like why, why go to the, all you've got then is the Java memory model in terms of transaction, concurrency and thinking about how that fits together. And then if you had a means to easily let other processors on other machines see that memory and use it easily, then really that's literally what we're kind of broken the problem down to these days, right?
So but my experience with shared memory over machines was mostly a theoretical work and a disaster in terms of performance. So it was more from operating system point of view. But if you want to scale, so all the solutions I showed here are scaling with the machine itself. If you have to scale other machines because you need more CPU, you can't buy more memory or better hard disk or whatever, then I have quite cool experience with Hazel cards, spreading this over machines, and then using the technique to persist and lazy load hash maps. And then you can use exactly, for example, MapDB or whatever, and just store this stuff. But again, you have to push everything in Hazel cards, and Hazel cards means you're back on core data structures like hash maps. And distributed graphs, I was not able to find actual research that was able to give me an answer on how to distribute a graph over nodes, because even Neo4j, they're just scaling per machine. They're not scaling over different machines because you can't handle graphs over machine orders effectively. So the mathematical point of view, I was not able to find a solution. So if someone has research paper on this stuff, I'm really, really interested in this. Because this is the pain, even if you're thinking about microstream, if you have this graph, in the end, you must break down your data structure in Potion that fits at least in one machine. So as most people are able to do this because the data is not too complex, but if you have the challenge that your graph itself, the entity of one graph is bigger than the size of the machine you can use, you're lost. And then you have to break out the graph, you have to break the graph. If you're breaking graph, you have immediately distributed transactions, and distributed transactions are mostly pain in the whatever, and you have a central point of dealing with these transactions. And then you have a huge infrastructure monster, and then you have just use Cockroach or whatever. So this Cockroach DB or Elscast, Cassandra or whatever. Don't think about it by yourself. But if you can have it in dedicated entities, Hazelcast persisting is one thing, or just split it up with a distributed hash table by yourself over the entities.
Yeah, cool.
Yeah, but I think it's a very rare use case. So most people just 2 million entries, dumb down.
Yeah. Thanks for a question, Con, as always. And I think since people did raise their hands, they can still write questions on the meetup, and we are happy to forward it to Sven, and he can definitely answer questions. Sven, I think you might want to share. Are you gonna share the slides as PDF? You would like to do it?
Yeah, I can do it. So first thing is we have the show notes, and Jfrog is looking how many people are downloading this PDF.
Yeah. Awesome.
So this is the easiest way to come share. I think jfrog.com/show notes, and then you will find the link. And I think the tiny URL was bit.ly was, I think,
yes,
JVM melp jfrog together.
Yeah, I posted it.
We're shared. Yeah, so we'll share the links. Yeah. Otherwise, follow me on Twitter, follow me on YouTube, ask me questions, write me.
Awesome.
No emails. ping me via Twitter. Ping me via Twitter or whatever. It's the best way to get me.
Yeah. Awesome. So I think we are done, and we don't want to take a lot of your time. So I would really be really happy to kind of clap hands if people want to unmute themselves and cheer for Sven, at least remotely. Yeah.
Yep. Thank you.
The three of us.
Thank you very much.
The links that Sven actually mentioned, we're gonna be posting that in our social media channels, the Slack channel, Melp JVM, Twitter, as well as in our meetup page.
Yeah, I will give you the links and then distribute it, and I will reshare it immediately.
Cool.
Perfect.
Okay.
All right.
And otherwise, hope to see you soon again.
Vielen Danke, as you say.
Sehr gerne.
All right.
Okay.
Thanks a lot, the members, for joining in, and stay tuned for the next talk.
Yes.
Okay.
See ya.
Thank you. Have a good day.
Thanks,
Have a
guys.
nice one. Yes.
Hey.